Hi guys, so yes, we will continue with the system design for residential and C&I solutions, also with battery storage. So for residential, basically there is no like a magic formula that you can use, and yeah, in Hungary, the residential yearly net metering is over, so we need to focus on like daily usage, and also with the batteries, you have to count how many kilowatts does the customer uses every day, and plan the system to have enough capacity for not like a week of battery storage, but more like to have capacity for like the night. So we have to switch our mindset from like a weekly and monthly storage to have it like a daily basis. Basically, our ideal goal is to have a system that can produce as much electricity during the day that it supports the house loads and also charges the batteries enough to use the whole home appliances during the night from the batteries. And if you could do that, then it means that's going to be the minimum system usage from the grid operator. So basically, if the house can run on PV during the day, then in the night you can use the battery's electricity without using the grid as much as possible. So this should be like the main case for residential solutions. Back in the days, for example, for yearly net metering, you just only needed to calculate the yearly amount, the electricity usage for the household. Now you have to switch a bit because you don't have to calculate with the whole year production. You have to focus on like daily or weekly basis. For C&I, it's a bit, I think it's more easier because, for example, for us in Hungary, we have these quarterly our metering points, and with these points you can add it to a system. It's an Excel file, and you can add it to a designer system, and the system will calculate the optimal PV size and also the optimal battery storage size that you can install to the system to have the less possible losses on the zero export system. Because if you cannot produce back electricity to the grid, then of course it's a wasted electricity, so you should minimize that as much as possible. There are many systems for that and many softwares that can calculate the ideal PV size. For example, Deye that we use in Hungary. You can add the quarterly measured electricity usage from the point of use, and then the system will give you like this table on the bottom, and the more green the column is, that's going to be the system size that you have to use to have the minimal and the less possible losses on the system. So for example, if you have constant usage for the electricity and your PV plant is roughly the same as the constant usage, of course you will not have any kind of system losses for the zero feedback. But if you overshoot the consumption, then your system will be just working on a few percentage of the maximum that it could run on. Device compatibility for battery storages, it's going to be more like residential solutions. So to which inverter, which battery you can connect. And sometimes it's really a tough question, and we get it many times. For example, with Deye, basically for Deye you can almost connect anything that's low voltage, but we strongly suggest to use only Deye batteries, because if you connect like any low voltage batteries that doesn't have the communication with Deye, then you have to set the inverter to work on a voltage regulated charging and discharging. And if you are not aware or not completely understand the features and the technical parameters of the third-party battery that you're using, then it's going to be really hard to set the inverter to work right. So that's why we are trying to suggest to use Deye batteries, because if you have Deye batteries with Deye inverters, then it's really easy just to connect the communication, and you can just type in the amperes that you would like to charging the batteries, and the inverter will know what's the maximum capacity that it can charge and what's the minimum that it can discharge the batteries to. With Huawei, it's really easy, I think, because as you know, we have only two options for battery storage. The S0, the previous one batteries, and the S1, the new one. Here, it's just a half S1 battery, but the bottom you can see it's the 7 kilowatt hour, and the S0 is the 5 kilowatt hour. So for the hybrid inverters, you can use either the S0 or the S1 battery storage system. It doesn't matter if it's one phase or the three-phase inverter. Both batteries work with any kind of hybrid inverters. The only thing you have to keep in mind here is that in one single system, so if you have, like, let's say you have a hybrid MB0 inverter with 2 battery inputs. You cannot put the S1 and the S0 in a system together. So you have to use either one of them. You cannot mix it in one single system. For C&I solutions, we have the Luna, the 200 kilowatt, 215 actually, the new one, because it's an AC coupled battery. That means it connects to the grid on the AC side and not on the DC side. You can use it with any kind of third-party inverter, but of course, it's the best to use it with Huawei systems and Huawei PV parks. So because on the AC side, there is no communication directly between the two brands, for these cases where you have a third-party inverter, you have to use an EMS in order to control the PV and control the BESS in the same time. With SolaX, in residential solutions, we have two common inverters, the X3 G4 and the Ultra. Ultra is the bigger one from 15 to 30 kilowatt, and the G4 is the small from 5 to 15. As you can see on the picture, I think it's just mismatched. So the X3 G4 should be on the top, and you would see like the HS25, the T58, the T30, it's all compatible with the residential solutions. But for the Ultra, it's only the T55 and the HS25, which is compatible with them. And it's good to keep in mind that if you would like to place the batteries outside, the HS25, the HS26, and the HS51, so basically the HS series, are the ones that you can put outside because they have the heating, they have the needed IP protection, and the T series are meant for indoor usage only. So these are the main differences between them, and that's how you can connect to the inverters and use with them in a single system. With Deye, we have a low voltage and high voltage series of inverters. This one is the low voltage. Recently, there was a new model change from the previous models that you can see here on the wall. It was the previous one, and now they made like a facelift version of the new inverters. It's more like aesthetic appearance. From technical point of view, it's almost the same as it used to be. So for the low voltage inverters, these are the 4 recommended batteries that we have in stock and we suggest you to use. I think you're familiar with them already. It can either work with the single phase or the 3-phase inverters also. For the high voltage series, there was also a model refreshment, like a facelift. And the main model that we are using with the batteries is the Boss G. And of course, if you would like to have the cabinet solution batteries, it's going to be the GF60 or the GF120. It's basically made of Boss G batteries, but it's pre-assembled in the Deye factory, and it's suitable for all outdoor usage. So you just have to install the whole cabinet. The batteries are connected inside. You just have to add the inverter on the side, connect the DC, and it's ready to go. So these are I would say, the top 3 high voltage batteries that we suggest to use with the high voltage inverters. Thank you.